Hey everyone, I got another example of a story problem here, one that would possibly be on, that was possibly on the test that you guys took earlier, I think last week. It says, suppose that a lawn can be raked by one gardener in 3 hours and by a second gardener in 8 hours. How long will it take two gardeners to rake the lawn working together? I struggled to come up with the equation for this problem because it doesn't give you a lot of information, and what you really need to do is you need to think, okay, if gardener number one rakes it in 3 hours and gardener number two rakes it in 8 hours. Really, if gardener number three or one does it in 3 and gardener number two does it in 8 and they do it together, well, obviously then this guy's gonna not take 3 hours this time. It's going to be less than 3 hours. So a lot of students will say, okay, the answer should be between 0 and 3. Well, let's think about this. If you had gardener number one and gardener number two who both raked at the same rate, so they both raked at the same rate, you can think about doing chores at home and saying, all right, if I want to wash the dishes and I get my brother to help me wash the dishes, typically what people would think is, well, that should take you half the time to wash the dishes. That's why we ask people to help us do things, because it takes half the time. But that's only true if they actually work at the same rate. In this case, they're not working at the same rate. So if they were working at the same rate, say gardener number two also did the lawn in 3 hours, then we would say, obviously, if it took 3 hours and 3 hours for each of them to do it, well, when they do it together, it's only going to take an hour and a half. It's going to take half the time. But because this guy is this gardener number two is much slower, we can estimate, so this is our estimate, we can estimate that the time is going to take us between 1.5 hours and 3 hours. Because we know it's not going to obviously take him 1.5 hours. It's going to be more than that. But it's not going to take longer than 3 hours because they're working together. So we know that it'll be between 1.5 and 3 hours. So then from there we can start to break this down. We know they're each going to work at least an hour. So if they each work an hour, how much of the yard will this guy actually do in that 1 hour's time? Well, he's going to do 1/3 of the yard in that amount of time. Okay? So this guy, if in 1 hour's time, is going to do 1/3 of the yard. This guy is going to do 1/8 of the yard. So if we take 1/3 of the yard plus 1/8 of the yard, if we do 1/3 of the yard plus 1/8 of the yard, that's what they're going to do in 1 hour's time. Okay, so that should make sense. 1/3, this guy's going to do 1/3 in the first hour. This guy will do 1/8 of the yard in the first hour. So we need to add those together, and that's what happens in the first hour. So then we find a common denominator. So 1/3 and 8, so obviously our denominator is going to be 24. So we'll multiply this by 8 over 8. And we'll multiply this by 3 over 3. And we'll end up with 8 over 24 t plus 3 over 24 t, which equals 1. Add those together, you get 11 over 24 t, which equals 1. And then we can multiply by the inverse. So we're going to multiply this by 24 over 11, and this by 24 over 11. And this is obviously going to cancel, give us t equals 24 over 11, which when you divide that out, it gives you roughly, I believe, 2.3. So 2.3 hours. And we know this is true because our estimate was between 1.5 and 3. We got something in between there. We can assume that that is correct.